Hi guys, so welcome to our third question of binary search series. So that is median in a row wise sorted matrix. So what the question says, you have a 2D matrix which is row wise sorted. Let's consider 1, 3, 5, 2, 6, 7 and 2. Let's say that is 3, 6 and 9. Okay, so this is our 2D matrix where every row is in sorted order. You can look at every row that is in sorted order. You have to find the median. What is median? If there are n elements, then n plus 1 by 2th element is your median for odd number of element. When n is odd element, okay, is median. Now for even there will be two median, but you have to find only one. Okay, so here if you like write it in a sorted order, 1 2 3, again 3, then 5 6 6 7 9, which is a mid element, that is 5. So this is nothing but your median. How you can identify? There are total 9 number of elements. So 9 plus 1 by 2, that is equals to, you have to find fifth element. So 1 first element, second element, like that, third, fourth, and it is your fifth element, that is median. Okay, so this is about median. Now let's to solve this question, what you can do. Now this can be a very simple approach to solve our question. Like first flatten the 2D matrix into a one single dimensional array and then sort this and pick the n plus 1 by 2th element. Isn't it? This is a simple approach to solve the question. Before that, let's also look for a even number of element, that is 1 2 3 4. So here our n equals to 4. 4 plus 1 by 2, if we took only integer part, that is equals to 2, and 1 2 3 4. So our median is 2. This is our median for even number of elements. Now 3 is also a median, but we have to choose any one. Like we have to choose the first one, first median. Okay, so how we can go? Our first approach one can be flatten 2D matrix in single dimensional matrix, single dimensional array, sorry. So now to do this, what will be the complexity? That will be nothing but order of n square. You can do it in n square using each row is sorted. Okay, so yes, so you can just flatten it here. You don't need to sort. Then after the next step, you can sort it. Okay, it will take time of n square, log n square, nothing but log n square, and log n is same. So this will be the complexity for sorting. And at the third step, just pick median. It will take constant time, and space you will be required of order of n square to store this single dimensional array. Okay, and what is the maximum complexity of the program? That is, you are getting order of n square log n. That's the complexity you are getting. Can we improve this? Obviously we should improve this. So let's see how we can improve this. Approach to how to decide a number m is median or not. Now, before some time we are interpreting the question as finding the median, isn't it? Now we are interpreting the question like that we have a number. Can we decide that is it median or not? Okay, so why we are doing that? Because so that we can apply binary search. So again, that low and high concept we will get mid, and we so that we can check if mid is a possible median or not. So let's go step by step. So how to decide m is a median or not? So we will have our matrix. We will see. We will find out that count, which will represent number of elements, but number of a number that is less than equals to m, total number that is less than equals to m. If that number is equals to n plus 1 by 2, if count equals to n plus 1 by 2, in that case we can say m is a possible median. Now why possible median? Why I am not sure? Look at here. Here, if I talk about 5, how many elements are here which is less than 5? Less than equals to 5. Here we have 3 elements. Here we have 1 elements. Here we have 1 elements. Okay. So, okay. So total we have 5 elements which is equals to n plus 1 by 2. Fine. Now consider, let's edit this array, convert 6 to 7 and this also to 7. Now consider about 6. Now you know that 6 is not present, but I want to check 6 is a possible median or not. How many elements that is less than equals to 6? 3. How many here? 1. How many here? 1. So total 5 elements which is less than equals to 5 elements which is less than equals to 6. But can you say that 6 is your median? No, because 6 is not even present in your 2D array. So if m is a median, then count should be equals to n plus 1 by 2. Then m is a possible median. And now if m is present in that array and m is the smallest number, I can say if m is the smallest number for which count is equals to n plus 1 by 2, then m is surely our median. Like there you can see that 6, we are getting 6 also a median. But is 6 is minimum? No. What is minimum? 5. And obviously the minimum number will be present in the array because we are imposing the condition that is less than equals to. Less than equals to. So the boundary element will be equals to that element that is present in there. So that's why we can change our definition to like that: smallest number for which count is n plus 1 by 2. Then m is surely our median. We can be sure that yes, m is our median. Okay. So now, so how we can go forward with this? So we can apply binary search. Let's come to algo, not code. Let's write the algo. Okay. So low. What can be low and what can be high? For that, first let's take the matrix here. Okay. So the minimum of our matrix can be, minimum of our median can be anyone from this first row because the minimum elements are here, isn't it? So low is minimum of first column, and high should be maximum of last column because all biggest number present in the last column. So you can choose the maximum. So here it is 1. For now we have 1, 1, and here we have 9. So our median will be present from 1 to 9. So we can write binary search logic here. While low is less than equals to high, we can find our mid, that is int mid equals to low plus high by 2, low plus high by 2. So and int count, that is count elements, that is less than equals to mid. Okay, so we have to pass the array, the matrix. Let's write it down, m matrix, and I have to find out how many elements in the matrix that is less than equals to mid. Okay, when we have this count, if this count is equals to n plus 1 by 2, then what? Then this can be a possible answer. Answer can be our mid, but there also one answer can be present that is less than mid. So we will reduce our high to mid minus 1 to check in the range be like left of mid. Is there any more solution present? Is there any more solution present which is less than mid? In that case, answer will be again overwritten. Okay. So else if if count is greater than n plus 1 by 2, that means, so before median, let's say we should have 5 elements, but now we have more elements which is less than equals to mid. That means we have to reduce the range, like we have to reduce the high to get more less element. Like consider this array, when your mid will be 7, how many elements will be there? Here 3, here 2, and here more 2 elements. So total there is 7 elements, which is more than 5. I need only 5 elements. So this range is very big type. That's why we are getting 7 number of elements. So what we can do, we can take our high and reduce it to 6 so that our mid will be less than 7. So we can search in that range. So if it is in that case, high will be our mid minus 1, and at the else case, obviously when count will be less, very less number of elements we are getting, less than equals to m, that means value of m should be increased, and in that case, so low will be increased, updated to mid minus 1. That is all about while, and we can return our answer. That's all about the program. Now let's analyze the complexity. Now obviously here we are doing binary search in which range? In the range of maximum value of the matrix and minimum value. So the binary search complexity will be max value minus mean value of the matrix, and for each call, for each binary call also we are counting the number of elements which is less than equals to mean. Now how you can do it? You can do it using binary search, because the that's why the point comes, the matrix is row wise sorted. So in that first row, how many elements are there which is less than equals to mid? You can find it out using binary search. Using binary search, because it is sorted array, so you can do binary search and find it out how many elements that is less than or equals to mid. So you have to apply binary search in each row. If there are, let's say it is a n cross n matrix, we are taking it as a square matrix, but it not mandatorily. So for complexity we are assuming, okay, let's assume m into n. This is an m into n matrix. So m times you will do binary search in n elements. Okay. So your complexity is m log n into log max minus mean. Isn't it? So using binary search, or complexity is order of m log n and log max minus mean. What was complexity in brute force? In brute force, the complexity was order of n square log n, in case if both are n into n dimensional, otherwise that is mn log mn. So which is better? Obviously you, if you compare mm, that cancels out, and this is better, this is much better, isn't it? N is very bigger than log n for large number of values. So let's go for implementation. So here is the question. So first we will define our law, that should be the minimum of first column, that we will find it out. For now we are writing it as int max, because we have to find the lowest value. So we are initializing with a max value, I equals to int min. Just a minute. Okay. So and we will have our answer, sorry, we will have our answer as -1 for the first time. Okay. So now while, okay, before that we have to initialize low and high. Okay. Okay. So for int I equals to 0, let's define n and m. M equals to matrix dot size and n equals to matrix of 0 dot size. N is number of column and m is number of rows. So I equals to 0, I less than m, I plus plus, low equals to minimum of low itself or the matrix of ith row and 0th column and 0th column. So like that we can find out our high, that is minimum not, that will be maximum of current high and matrix of 0 I comma last column is m minus n minus 1. Okay, so now we can start our binary search while low less than equals to high. For that time we will calculate our mid, and our mid will be low plus high by 2. Then we have to find out, well, what we have to do. We have to count the number of elements that is less than that element. Okay, so in that case what we can do, for each row we have to do it. So for int I equals to 0, I less than m, I plus plus. So we have to count int count, that is initialized to 0 for each row. Now for the first row we have to count. So let's say now we can do that searching, that binary search, using a built-in function, that is upper bound. Upper bound does the same things. What upper bound does, let me write it down here only. So if auto position equals to upper bound in the matrix of I dot begin. So we are searching in the ith row begin to end all over for the element mid, So what does upper bound does? Upper bound returns element in the row greater than the first element, I should say, first element in the row or in the array greater than mid. Return the first element position or iterator, to be specific, iterator. So this is how upper bound works, and it applies binary search. So when you are passing something to upper bound, you should be sure that that is sorted, isn't it? And here every row is sorted, so I don't have any problem. Okay, so what will be the distance? Distance equals to distance. Here it is also a built-in function. So matrix of I dot begin to position. So that's all. If the first element itself, it's the first element of the row itself, it is greater than that is 5, so it will be returned. So in that case distance will be 0, so we have no problem with this calculation. So we can add it to our count, how many elements are there which is less than. So it gives number of elements less than equals m. or mid. Okay, so we have our count. Now here we can do if count is, so we can define our median position as m into n plus 1 by 2. Okay, total number of elements by 2. So here total number of elements is m into n. So if count is less than equals to median, sorry, if it is equals to median, in that case it is a possible answer, and we will reduce our high to mid minus 1. We will reduce our range. Else case, else if count is greater than median, that is we are getting more number of elements than expected, so again we will reduce our high, and at the else case we can increase our low to mid plus 1, and at the last we can return our answer. So that's all. Let's compile it and let's see is there any error or not. Now we are getting a right answer. Let's also check for another input like this. So that is 3 1 1 2 3. Okay, so let's submit our program and let's see. Okay, there is some problem. My code's output is -1, but the correct, no, -1 cannot be the output ever. So there is some problem. Let me see. N is okay. So we are finding the maximum range from n minus 1 at column. Okay. And we are setting our median as this. Fine. Low is less than equals to high. Until that we will calculate mid and count. Okay. Yes, count will be 0 every time the loop start. There will be distance. No problem. So what is the problem? From begin to end we are searching for mid, and then we are taking the distance and adding it with our count. Okay, so let's do one thing. Instead of this, let's combine. If number of counts is greater than also, we are considering this can be an answer. Still we will get our answer because we will find a minima. High will be again reduced, so it will be overwritten. So let's see with this, is something change or not. Yes. Okay, so actually what was our problem? There was some problem with equal elements. Like if you look at this, when you have 2 2 and 2, let's say these three elements. Okay, if you see, like if you check if 2 is a median, in that case what you will see, what is the number of elements that is less than equals to 2? Whole three elements, which is not equals to n plus 1 by 2, but it is greater than equals to n plus 1 by 2. That's why 2 also can be a possible answer when the all elements are equal. That's why the problem was there. So we can fix it by merging this, or like keeping the mid as answer when all count is greater than median also. So that's all for today. This is a very good question, and I think deserves this. This came in many interviews also. Okay, so there is nothing written here. So that's all. Okay, let's end our class for today. Thank you.